How does ACT work? Well, you might be asking this question if you've ever seen this error before. I get this error quite a lot, and for a long time I really didn't know what was going on, and so I finally got fed up and looked into it myself because I couldn't really find anything good on the internet that explained what was happening. There were a lot of blog posts and a lot of Stack Overflow questions that gave solutions, but didn't really explain why the things they said would work. So that's what I'm going to do here. So my question is, how does React's ACT work? Basically, if you don't want to watch the whole video, it wraps some work that you'd like to do and waits for that work to complete before returning. That's about it. So when you wrap something in ACT, it makes sure that the thing inside of ACT is going to finish before you go on to the next line. So this is really useful when you're writing tests because you want to make sure the action you're going to take is complete before you start asserting against the results. And why do you get this error? Well, again, if you don't want to watch the whole video, it's because some update is happening to a component inside of a test, and that update is not happening when the thing is wrapped in ACT, basically. So one of the really common causes of this is if you have like a network call inside your component, and let's say you click a button in your test and you wrap that click in an ACT, all good, everything makes sense. But then the network call comes in, whatever, on the next event tick or a couple seconds or whatever it is, that update is not going to be wrapped in ACT because it's happening after the fact. So that's a really common cause of this error, is when you have side effects that are happening over time. So to understand what's going on with ACT and why it's necessary, we really have to dig into how React renders things and what the model is behind React, at least for updates. And so I made a really simplified diagram here. I'm not a React expert. I'm not a developer there, but this is how, after digging through the code, this is how I understand it to work. And I think this is a useful mental model to understand what ACT is doing. So let's say you have a component and you have a click handler. You click a button, for example, and that button click is going to update the UI. It's going to, maybe it's going to update a counter, and it's also going to create a network request. React needs to handle both of those events and maybe some events that happen because of those events, right? So let's imagine these green boxes are like events that are happening. We have this queue in the background that's in red, and then we have this like purple render function, which is the stuff that actually gets painted to the screen. So basically what happens with React is I click the button, oh, I need to update the UI, so it creates a little event, and that event is stuck in a queue, and our renderer will pull items off the queue whenever it has free time and whenever it needs to render something. So if you imagine there's something, the renderer is checking the queue all the time, probably hundreds or thousands of times a second, to make sure your UI stays responsive. The reason we have a queue structure here versus, why doesn't the update UI tell the renderer to render versus put a work item on the queue? Well, you could imagine that if you have each sort of UI update or state update telling the rendering to happen or telling React to do something, they might conflict at certain points. How do you know which one is more important than another, right? And so they actually switched to a queue sort of system. And the overhaul of this is called React Fiber. So if you look at the code, I think this happened in React 16. They rewrote sort of the event architecture behind the scenes of React. And basically, the Fiber re-architecture enables pausing, resuming, and reusing work as needed. So it's more efficient than what came before. And basically, it makes sure that the UI stays responsive. So you only have, like 13 or 16 milliseconds per frame to do your render. And you really want to make sure that like your click handlers are very fast, but maybe your network requests, those can wait, a couple more milliseconds. So you want to have some idea of priority and being able to pause things when more important UI updates come in. So that's one of the advantages you get here. And that's the architecture that React uses today. uses this, what they call fiber, to render all of the different updates that are happening. So that's the sort of general architecture of React there. We have our events that are coming in, getting put into a queue, and then the renderer will look at that queue and peel off work items and complete them. So that's what's happening in the browser. What happens when you're running a test? Well, we know that React still has this queue going on in the background when you run the test. But the queue is independent of the test. It doesn't happen synchronously. This is all happening in a sort of a separate place, asynchronously, right? So our test doesn't know if there are any items on the queue. If I click a button and then I assert that some state is different or that the a counter has increased because of the button click, how do I know between the time I click the button and the time I assert that React has actually done its job and updated the state? Well, you don't, because they're two separate systems, right? So we need some way for the test to know about whether or not React is done rendering things, is done with all the items in this queue. Well, that is exactly what act does. So basically, if we go down here, we give our act function a callback, and basically when you call act, it'll create a new queue for you, and it'll put that in place of the one up here that's being used in normal sort of production times. So when you have act, it'll replace that queue with just a temporary one called the act queue, and then what'll happen, it'll run your callback. So this is like button.click or render or something like that, right? That's the code that goes inside your callback. And when you run that code, different state updates will happen. And those state updates will go, instead of onto this normal queue that is independent of our test, they will go onto the act queue. So we do our callback, we do some updates via props or state, and then we add some items to our queue. And what act will do, instead of running the queue sort of independently in the background, act will force the queue to finish before the act function returns. So basically, we're adding items onto our queue, then we're going to execute them, and so on and so forth. And we finally get to a place where our queue is empty, and then act will return. So that solves our problem of how do we tie our test environment? How does our test environment know that the queue is empty? Well, act is going to ensure that. And that's basically it. So we go back to our notes here. Why do we get this error? Well, that's because when act, let me put it this way. I'm going to put this. When we're rendering, when we're doing an update, and that update happens on this queue, we know something is wrong when we're actually running tests, right? So it knows we're inside a test, and it looks and it says, have we added some items to this queue, or have we added some items to this queue? And if it's the first one, if we add items to this, it goes, oh, that's probably not right, because now your test and your React component are going to be unsynchronized. We want to make sure they happen at the same time. We want to make sure that our updates are going to be completed before we start asserting against things. So that's what it's telling you. And the most common cause of this error, if you're doing everything right, if you're using, say, React testing library and wrapping your button clicks in act, is side effects like network calls or things that cause components to update sort of after the fact or asynchronously. And if you want the details of how this all works, I have in my little notes doc here, which I'll attach to the video and a gist, all the places where act is defined and how the scheduler works and what an act queue is and all that. But really the TLDR is act acts on this queue and replaces this sort of production queue that happens separate from our test and replaces it with one that is synchronized to our test, or at least it'll make sure that this queue is empty before act completes, which is exactly what we want. So hope that clears it up, and good luck with your testing.